Hopefully you've had a chance to look over the homework problems from last night. As a reminder, we will have a quiz tomorrow over section 2.1 to 2.3. And if you have any questions over that material or any of the homework questions you weren't able to get, make sure you've checked over the answers on Schoology that I posted. And if you have any questions on that, I will be in my classroom in room 208 starting at about 7:30 Friday morning. So please make sure you give that a peek. So we're going to go ahead and go over section 2.4, which is on deductive reasoning today, and there are just some key vocabulary and some things to be aware of here. We're going to go ahead and go to this slide here, hopefully. Okay, so deductive reasoning is essentially another way to make progress in logical reasoning. So deductive reasoning is the process of reasoning from given statements to a conclusion. This varies. We're going to spend the next couple days after the quiz just kind of developing this idea a little bit more in terms of the differences between inductive and deductive reasoning. But inductive, remember that we looked at patterns, and from those patterns we tried to establish, make a conjecture as to what would come next. Deductive reasoning is we're actually given some statements of fact, and then we're trying to take that to conclusion. So when I get back, we'll talk more about the differences there, hopefully do an activity that will hopefully illustrate those differences a little bit more clearly. But here's an example. So if a person wants to run a marathon, then he or she must train hard. Jillian wants to run the Boston Marathon in April. What conclusion can we make? So if you want, I would like for you actually to pause for a second and just go ahead and answer that question. All right, so hopefully you had a chance to think about that idea a little bit. So probably the right answer here would be that Jillian needs to train hard. And this actually is an example of what we call the law of detachment in logic and logical theory, those kinds of things. Law of detachment essentially says that if a given conditional is true and the hypothesis of a separate related statement is true, then the conclusion is true as well. Okay, and so we can see an example of that in the previous example, that this essentially is our initial conditional statement. If a person wants to run in the marathon, then he or she must train hard. And in this case, then Jillian actually is an example of a person who fits into this category. So she's a specific example of a person who fits into that hypothesis statement. She wants to run a marathon. Therefore, the conclusion, this part here, which follows, this part has to be true about Jillian as well. Since she fits into this part, the hypothesis, she also has to then fit into the conclusion. And so that's what we call the law of detachment in logic theory. So the example here represents the law of detachment in symbols. So basically what we have here is if P implies Q is true, and something fits into P, or P, whatever that hypothesis is actually saying is true, then that necessarily follows that Q is true. And so we see that in the previous example with Jillian. This is just more of an example of, logically how we would represent that idea in terms of symbols that we've been using the last couple days. All right, if you flip to the back, we'll try another page here. Okay, so here's our example. If it is Thursday, then you ride your bike to school. If you ride your bike to school, then you wear your helmet. What can you conclude? So take a second to think about this. Go ahead and hit the pause button and go ahead and write out an answer like you would if you were in class, and I'll wait. So hopefully you've had a chance to think about that. And so what we want to conclude here is the idea of really piecing two of those statements together. And so we'll write here, if it is Thursday, you wear your helmet. And so this is what we call, it's actually an illustration of the law of syllogism, which I did not name, but it certainly kind of sounds like my name a little bit. So this is the law of syllogism. And basically all this is doing is allowing us to state a conclusion from two conditional statements with hypothesis of one is the conclusion of the other. We'll go back and take a look at how that actually applies to this statement, this example problem that we just did. And so the basic idea here is that if it is Thursday, then you ride your bike to school. So we have a conditional statement here, we have a hypothesis, we have a conclusion here. And so the second statement that follows that is actually an instance of the conclusion from the previous thing, right? So here we have this, that if it's Thursday, then you ride your bike to school. If you ride your bike to school, then you wear your helmet. And so it's connected by that piece. That's the bridge that connects those two statements. If it's Thursday, you ride your bike to school. If you ride your bike to school, then you wear your helmet. And so what we can decide from that then is any time that it's going to be Thursday, at least according to the statements that we have, and that's kind of our universe, that's really the only thing that we have to go on is those statements. So if it's Thursday, you ride your bike to school. If you ride your bike to school, then you wear a helmet. So we can sort of get rid of this bridge because it's connected. Really, it's connected within those two statements. And so we have, if it's Thursday, then you wear your helmet to school. Probably have to sneak that one in here. So then you wear your helmet, which is sort of implied in the way that I had written before. All right, so we can represent that law then in symbols as well. So we have if P implies Q is true, so that would be one statement, and Q implies R is true. Go ahead and fill in that last blank. Pause for a second, and then we'll come back together. All right, so hopefully you got this, that P implies R is true. And so that's sort of our shortcut. Again, we're sort of, the bridge that connects those two statements is Q in this case. And so we can go directly from P to R, or P implies R, rather. Okay, so here's an example, a couple examples to follow here. If I study all night, then I will not be able to watch Jimmy Kimmel Live. Bummer. If I have a math test tomorrow, then I will study all night. If Tyler comes over, then I have a math test tomorrow. Tyler comes over, what conclusion can be made? I'll give you a second to think about that one. All right, so hopefully you paused it and had a chance to think. And so the answer to this is essentially this, that I will not be watching Jimmy Kimmel Live. This is kind of a little bit of a combination of both of those previous laws that we talked about. And so what we really have here, we start with this. I might just write this down here instead. Sorry, I'm kind of all over the place with this one. But Tyler comes over. Okay, let's just kind of track the logic of this. So if Tyler comes over, that is a given piece of information. Okay, and from the statements that we have, again, that's our universe of knowledge to pull from. If Tyler comes over, then you have a math test tomorrow. So Tyler coming over implies that there will always be a math test. And we'll go back to the previous statement. If you have a math test tomorrow, then you will study all night. So whenever there's a math test, then you study all night. And then finally, if you study all night, then you will not be able to watch Jimmy Kimmel Live. And so that follows. It's a big law of detachment. There are several statements that are all kind of working together to kind of go directly from when Tyler comes over, there is a math test. When there's a math test, you study all night. When you study all night, you will not watch Jimmy Kimmel Live. And so that's our final conclusion, that you will not be watching Jimmy Kimmel Live. Okay, so let's take a look at the last example. Let me make a little bit of space here for this. And again, that previous one was called the law of syllogism. It essentially is just stringing several if-then statements together when there's commonality between the if and the then statements, the if and then parts. And so this last one, let's look at the example. What is the error in the reasoning below? Birds that weigh more than 50 pounds cannot fly. A kiwi cannot fly. Kiwi is a cute little bird from New Zealand, Australia, or I think maybe just New Zealand. So a kiwi weighs more than 50 pounds. True or false? And I guess what we would be thinking about here is what is the error in the reasoning below. So again, take a pause and think about that, make a response, and then go ahead and click play again when you're ready to go. So the idea here then is that the conclusion, I think, doesn't really imply the hypothesis in this case. So here we have a kiwi cannot fly, but if I take a look at the statement and try to work this into a hypothesis, if a bird weighs more than 50 pounds, then it cannot fly. That might be a way to write that as a more formal if-then statement in that traditional conditional statement form. So what we have really here is an instance of the hypothesis, right? The kiwi cannot fly, but that's actually the conclusion of the statement. So that doesn't really follow into that, the law of detachment that we looked at earlier. If we were to try to apply that, maybe we might say something like, so that's really the error in the logic, is that the kiwi cannot fly. That's an instance actually of the hypothesis, or sorry, the conclusion, rather than the hypothesis. And so maybe think about one that would work here in this case, and I'll give you a second to think about that. So not necessarily a kiwi cannot fly, but think about perhaps something that fits into the hypothesis of the statement. I'll give you a second to think about that. All right, so hopefully you paused and thought about that, but perhaps something like an ostrich. Right? I think about ostrich being a pretty big bird. Ostrich, R-I-C-H. Ostrich weighs more than 50 pounds. Okay, if that were our statement to begin with, now what we really have here, instead of this kiwi from before, now we actually have an instance where we have a part of the hypothesis. So birdie is a bird that weighs more than 50 pounds, therefore it cannot fly. So this would be our law of detachment. We have something that fits in here, and our conclusion would be the ostrich cannot fly based on our hypothesis and our conclusion of the statement before that. Okay, so that's all I have for notes here. There are some follow-up problems that I had on the previous slide. I'll also have it up on Schoology, and so the substitute will also maybe have those available. So go ahead and feel free to work on that. For the rest of class, good luck. I'll see you tomorrow.